Today we're going to be learning about solving problems with quadrilaterals. First, let's quickly take a look at the process that we're going to follow for solving quadrilateral problems. The first thing you need to do is identify the type of quadrilateral that you're working with if they haven't told you what it is. So you need to use any information that you've been given, like the length of the sides, the angles, if the sides are parallel, and so on, to help you to identify if it is a square, a rectangle, a parallelogram, a rhombus, a trapezium, or a kite. Once you know what type of quadrilateral you're working with, you can use its properties to help you to solve the problem that you've been given. So whether that's proving something or finding out the sides of something and so on, you can use the properties of the quadrilateral to help you to solve that problem. Okay, let's have a look at an example. In this example, you've been told that AB equals BC equals CD equals AD. You've also been told that this angle over here is 70 degrees, and you need to work out the value of x. Okay, so let's go and have a look at how we would solve this problem. Okay, so the first thing we need to do is identify the type of quadrilateral that we are working with over here. Now, they told us that these sides are all equal to each other, but they haven't told us what type of quadrilateral it is. So the first thing we have to do is identify it. Okay, so for this question, in order to identify the type of quadrilateral, I first have to write down the information that I'm going to be using that helps me to identify it. So based on what I can see here, because I have all four sides equal, that means that this must be a rhombus. So I'm going to write down first that AB equals BC equals CD equals AD, and that information was all given to me. Okay, so I first write down the information and how I know it. That will help me to identify what type of quadrilateral it is, and then I can say, therefore, ABCD is, in this case, it's a rhombus. And I need to give my reason, which is that all four sides are equal. Okay, so when you are identifying the type of quadrilateral, you first write down the information that helps you to know what it is, and then you state what it is and you give the reason for it. Next, we need to look at how we're going to work out what x is. Okay, so first of all, I've got 70 degrees over here. Now, I can use that 70 degrees and I can prove that this angle over here is 70 because these lines are parallel, because it's a rhombus. Okay, but that still isn't enough for me to work out what x is. I need another angle, because if you look, if it's in the same triangle over here, I know what that angle is. I need this angle, but I don't have this angle over here. But a rhombus is special because the diagonals bisect each other at 90 degrees, which means that I know that this angle over here is going to be a right angle. So I'm going to go and say that angle O4 is a right angle. It's a 90-degree angle, and the reason I know that is because this is a rhombus and the diagonals in a rhombus bisect each other at 90 degrees. Okay, so now I know that this angle over here is a right angle. Right, so I've got one of the angles in the triangle that contains x. Now I need this other angle to help me to work out x as well. So like I said, we can prove that this angle is 70 degrees, but first I have to say that these sides are parallel, because otherwise I can't prove that this is 70 degrees. So these two sides are parallel because this is a rhombus. Again, it's one of the properties of a rhombus. So I can say that AD is parallel to BC, and my reason is that the opposite sides of a rhombus are parallel. Okay, so now I know that these are parallel over here. Right. The next thing I'm going to do is, because I know that they are parallel, I can say that these angles, which are alternate, are going to be equal to each other. So I can say that angle C1 is equal to 70 degrees. So therefore, angle C1 equals 70 degrees because of alternate angles with AD parallel to BC. Okay, so now I know that this angle over here is 70 degrees. So now if I look at this triangle over here, I can use the interior angles of that triangle to help me to work out what x is, because I know what that angle is and I know what this angle is, so I'm just missing this angle, which is x. So now I can go and work that out using the interior angles of the triangle. So therefore, x is equal to 180 minus 90 minus 70 is going to be 20 degrees. And the reason I know that is because of the sum of the angles in triangle BCO. So that's how you can work out the value of x in that example. So the first thing we did is we identified the type of quadrilateral. And remember, when you identify the type of quadrilateral, you first have to write down the information that you are using to help you to prove what that quadrilateral is. So in this case, I had to write down that all four of those sides were equal to each other, and how I know it, I knew it because it was given to me. And so then I can say, okay, it's a rhombus, and the reason I know that is because all four sides are equal, which are these ones that I said over here. Once I know what type of quadrilateral it is, I can then use the properties of that quadrilateral. So the properties of a rhombus are that the opposite sides are parallel, and that the diagonals bisect each other, and that they are perpendicular to each other. So in this case, the ones that were helpful to me was, first of all, that they bisect each other at 90 degrees. The bisecting wasn't so much important, it was the 90 degrees that was important in this particular example. So the fact that, that the diagonals are perpendicular to each other, that helped me to get 90 degrees for angle O4. Then also the fact that the opposite sides of a rhombus are parallel helped me to work out what angle C1 was, which then helped me to work out what x was. Okay, so now I'm going to give you a few that you're going to do for yourself. In this first one, you have been given a quadrilateral and you need to work out the size of angle A. Now for this particular one, it's a little bit different. You do not need to identify a type of quadrilateral here, because you're going to be using a property that is true for all quadrilaterals for this particular question. I'm going to give you 2 minutes to work on this example. Okay, so let's go through that question and see what you should have got. So for this question, the first thing you had to do was remember that the interior angles of all quadrilaterals always add up to 360 degrees. So we're working with the sum of the interior angles of a quadrilateral here. So I'm going to say 2x minus 10 degrees plus x plus 20 degrees plus 2x plus 3x plus 50 degrees all equals 360 degrees. And the reason I know that is because of the sum of the angles in quad ABCD. Okay, so now we're going to go and solve for x. So here I've got 2x plus 2x plus 3x. That is 8x equals, then I've got 360 plus 10 minus 20 minus 50, and that gives me 300 degrees. Okay, so now I've got 8x equals 300 degrees, so now I'm going to divide by 8, and that gives me 37.5 degrees. So therefore, x is equal to 37.5 degrees. Okay, but now that's not what we were asked to work out. We weren't asked to work out what x is. We were asked to work out the size of angle A. So now to work out angle A, we're going to have to substitute in the value that we have here for x. So it's going to be 2 times 37.5 degrees minus 10 degrees. Okay, so now I've got 2 times 37.5, that gives me 75 degrees, minus 10 degrees, which gives me 65 degrees. So that's what you should have got for question A, that angle A is equal to 65 degrees. Right, let's go on to the next one. In question B, you've been told that EFGH is a parallelogram and you need to find the size of x. Okay, now when you've been told what type of quadrilateral it is, you obviously don't need to prove what type of quadrilateral it is, but you do still need to know the properties of that quadrilateral to help you to actually solve this problem. Okay, so I'm going to give you 1 minute for this question. Okay, so let's go and see how you should have done this question. So first of all, they told us that this is a parallelogram, which means that it has the properties of a parallelogram. So if I look at this, I need to work out what x is. Okay, now if you look at the information you've got over here, this is 62 degrees. Now if these two lines are parallel, then you can use the fact these are alternate, and alternate angles with parallel lines are equal to each other. Okay, so because they told me this is a parallelogram, I know that these two sides are parallel to each other because the opposite sides in a parallelogram are parallel. Okay, so I can start off by saying that these two sides are parallel to each other. So EF is parallel to HG. And the reason I know that is because they're opposite sides of parallelogram EFGH, and opposite sides of any parallelogram are always parallel. Okay, now that I know that these are parallel, I can go and fill that in on my diagram here. Because these sides are parallel, it means that these alternate angles over here will be equal to each other. So now I can say, therefore, x is equal to 62 degrees. And I know that it's equal to 62 degrees because of alternate angles with EF parallel to HG. Okay, so in this one we first had to use the fact that this is a parallelogram to say that those sides are parallel, and then we could use the fact that they were parallel to say that the alternate angles here are equal, meaning that we could work out the size of x. Right, let's go on to question C. In question C, you're being told that KLMN is a rectangle, and you need to find x and y. I'm going to give you 5 minutes for this question. Okay, so let's see what you should have got for that question. Right, so first of all, if you look at the diagram over here, we've been told that this angle is 136 degrees. This is where x is, and this is where y is. And we were told that this quadrilateral is a rectangle. And that's going to be super important for helping us to actually work out what the value of x and y are. Before we get to that though, if you look at where x is in this triangle over here. And we might be able to use the angles in that triangle to help us to work out x if we can find out more about it. This 136 degrees over here isn't really helpful where it is, but I can use that to help me to work out the size of angle O2. So I'm going to work out the size of angle O2 by saying, because these are vertically opposite, they must be equal to each other. So I'm going to start off by saying that angle O2 is equal to 136 degrees, and my reason that I can say that is because vertically opposite angles are equal. Okay, so now I can go and fill that in on my diagram, that this is 136 degrees. Okay, so now I'm a little bit closer to be able to work out what x is, but as it stands at the moment, I still don't have enough information to actually work out the value of x, because I only know the size of one angle in this triangle. I know that this is x, and I don't know anything about this yet. But this is where the fact that this is a rectangle is going to come into play. Now remember, a rectangle is special because the diagonals bisect each other and they are equal to each other. So because they're equal and they bisect, that means that this over here, this line segment KO, is going to be equal to this line segment ON. So I can say that KO is equal to ON. And the reason I can say that is because the diagonals of a rectangle are equal and they bisect. So diagonals of rectangle KLMN are equal and they bisect. Okay, so now I can go and fill that in on my diagram over here. That these are equal over there and there. Okay, now that is important because that means that this is an isosceles triangle, which means that I can now work out what x is. Because I can say that angle K2 is also going to be equal to x because they are angles opposite equal sides in that triangle. So I can say angle K2 is equal to x because they are angles opposite equal sides in triangle KON. Okay, so now I can fill this in over here, that this is x. So now I've got x and 136 degrees. Now I can use the sum of the interior angles of the triangle to work out what x is equal to. So I can say x is equal to 180 degrees minus 136 degrees all over 2. And the reason I can say that is because of the sum of the angles in triangle KON. Okay, now we can go and work out the size of x. Let's say 180 minus 136, and that gives us 44, and then divide that by 2 to get 22 degrees for x. Okay, so now I know that x is 22 degrees. Okay, now I am halfway there. I've done one of the variables. Now the other variable I need to work out is the size of y. Now to work out the size of y, I'm again going to be using the properties of a rectangle. Now remember, a rectangle is a special quadrilateral where the angles are equal to 90 degrees. So that means that I know that this whole angle over here, KNM, must be equal to 90 degrees because this is a rectangle. So now I can say over here that angle KNM is equal to 90 degrees. And the reason I can say that is because the angles in rectangle KLMN must all equal 90 degrees. That's one of the properties of a rectangle, that all the angles are equal to 90 degrees. So now I can go and work out what y is, because I know that x is 22 degrees, so that means that y must be 90 degrees minus 22 degrees, which is 68 degrees. And that's how you work out x and y in that example. Right, now let's go on to the last question for today, question D. You have to prove that PRST, so that's this one over here, PRST is a parallelogram. I'm going to give you 4 minutes for this question. Okay, so let's go through that example and see what you should have got. So first of all, in this diagram, you've been asked to prove that PRST is a parallelogram. Now we have a few different methods of proving that a quadrilateral is a parallelogram. If we can prove that there are two pairs of opposite sides that are parallel, then we know that it's a parallelogram. Or if we can prove that two pairs of opposite sides are equal, or if we can prove that two pairs of opposite angles are equal, or if we can prove that one pair of opposite sides is both parallel and equal, or if we can prove that the diagonals bisect each other. Now there are a couple of those that we can eliminate straight away. We don't really know anything about the angles at all, so we're not going to be working with the opposite angles option. And in this example over here, for this particular quadrilateral, only one of the diagonals has been drawn, the other diagonal has not been drawn, so we're not going to be working with diagonals bisecting for this one either. What we do have over here is this side. We've been told something about the length of it, that it is equal to this line segment over here. So RS we've been told is equal to QR. So we could potentially work with two pairs of opposite sides equal to each other, or we could potentially work with one pair of opposite sides parallel and equal. So if we can prove that this side is equal to that side and this side is equal to that side, then we can prove that it's a parallelogram. Or if we can prove that this side is equal to that side and that these two are both parallel, then we can prove that it's a parallelogram. So let's have a look at what else we have in our diagram that could help us to do one of those two things. So over here I've also got this shape over here, PQRT, which I could possibly prove to be a parallelogram as well. And if I can prove this one is a parallelogram, then its properties can help me to prove that this one is a parallelogram. So let's have a look at what we know about this one. So for this one, I have both of the diagonals drawn, and they've told me that this is equal to that, so PO is equal to OR, and they've also told me that QO is equal to OT. So they have told me that the two diagonals are bisecting each other. So that means that I can prove that this is a parallelogram. Now remember, anytime that we're going to prove that a shape is a parallelogram, we have to first write down the information that we have that we're going to be using to prove it. So I first have to write down that PO is equal to OR. And the reason I know that is because it was given to me. And I'm also going to write down that QO is equal to OT. Again, that was given. So because those are equal like that, that means that these two diagonals are bisecting each other, which means that this is a parallelogram. So now I can say, therefore, PQRT is a parallelogram. And the reason I can say that is because the diagonals bisect each other. Okay, so now if this is a parallelogram, that means that it has the properties of a parallelogram, including the fact that the opposite sides are equal to each other and the opposite sides are parallel to each other. So now I can say, therefore, PT is equal to QR. And the reason I know that is because the opposite sides of a parallelogram are equal. Okay, so now I know that these are equal over here. So this is equal to that. But they already told me that QR is equal to RS. So now if QR is equal to RS and QR is also equal to PT, that means that PT must also be equal to RS. So I'm now going to say, but QR is equal to RS, and that was given. Which means that PT must be equal to RS. Okay, so now I know that these two are equal to each other. So I've got one pair of opposite sides equal so far. Now, if this is a parallelogram, it also means that the opposite sides are parallel to each other. So if the opposite sides are parallel to each other, it means that this line is parallel to that as well, because this is all one straight line over here. Okay, so I can say that PT is parallel to QS. And the reason I know that is because the opposite sides of parallelogram PQRT are parallel. Okay, so now I know that these over here are parallel. Now, because I have now said that this is parallel to that and this is equal to that, I can now prove that this is a parallelogram. So I can say, therefore, I've already written those down, that PT is equal to RS and PT is parallel to QS. So I can say, therefore, PRST is a parallelogram, which is what I was asked to prove. And the reason I can say that is because there is one pair of opposite sides parallel and equal. And that's how you prove that PRST is a parallelogram in that example. So here we had to do a little bit of extra work. Before we could actually work on that, we had to first prove that this one was a parallelogram so that we could prove that these were equal to each other and parallel, which then meant we could prove that those were equal and parallel. And that is how we solve problems with quadrilaterals. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.